Okay, we're going to look here at solving now exponential equations. So solving equations where the unknown here is in the power or the exponent. So just a short note here that suggesting that the best method is to express both sides of the equation as exponents with the same base. So we've got some examples here, got 3 on the page. I'm going to work through these. So let's have a look at this first one. This is 4 to the power of x. All right, so what I'm looking to do, at 4 is probably a good starting point, 4 to the power of x. I'm looking to write 256 as a base of 4 if I can. It's a big power of 4, isn't it? But 256, let's think about that. 4 goes power 1, power 2, power 3 goes to 64, and power 4 goes to 256. So this will be 4 to the power of 4. So now we've got both sides of the equation with the same base. We can equate the powers or equate the exponents, so therefore x equals 4. Alright, now that, I guess 256, as came up in discussion today in class, recognizing sort of powers of with bases of 2, 3, 4, where the powers get up to sort of 3 and 4 can be a little bit tricky. So these are 4s, 3s go to these sorts of numbers, 81, 243. So having some kind of recognition of these numbers, 2 goes, perhaps you're a bit more familiar with 2. These are the powers of 2 as we go up, and you can expect probably to go to 128 or 256 here, because powers of 2 perhaps are a little bit easier to see, but 3 and 4 not so much. You're not going to go any beyond these values, I shouldn't think. So this is 3 to the power of 5, this is 4 to the power of 4. We've gone down to 2 to the power of 7 here to get 128, but those sorts of numbers are going to be useful for you because these are non-calculator questions. Okay, then go in here to 3 to the power of x minus 1. Let's write 81 now. Let's go to our little grid here. 3 to 1, 3 squared, 3 cubed, 3 to the power of 4. So 81 is 3 to the power of 4. Now we've got the same base on both sides. We can just say that x minus 1 is equal to 4, and therefore x is equal to 5. See, I've just equated now my exponents. Head over here to C, base 5, base 25. I can write these both with a base of 5, can't I? That 25 is 5 squared, so I bracket that. I put minus x plus 2 up there. My next step will just be to remove those brackets now, so it'll be 5 to the power of minus 2x plus 4. Therefore now I can drop my bases, my common base. I can just equate my powers. 2x minus 4 equals minus 2x plus 4. Alright, so putting all this together, I get 4x is equal to 4 plus 4, 8. So I've solved the equation x equals 2. I'm going to do one more example here, and it's just going to bring in another sort of technique, one that you might like to keep an eye out for. Alright, we're looking now to solve 9 to the power of x equals 12 times 3 to the power of x minus 27. Now, I guess what we're looking for here is, this is just looking a bit different. Firstly, this 12 times 3 to the x, that looks a bit weird. Can I write everything in the same base here? Well, no, I can't really, because this is a 3 times 2 times 2. That's not going to get everything in the base of 3. I can pull this down to a base of 3, and that can be a base of 3. But what actually we get here, is what we're looking to get is actually just 3 to the power of x and 3 to the power of 2x, and we're going to turn this into a quadratic equation. I'll show you how that's done. So firstly, let's get this 9 to the x. That's 3 squared to the power of x. Alright, I'm just going to rewrite this as 12 times 3 to the x minus 27. What I'm going to work on is this 3 to the x business. So that is equal to 3 to the... Actually, what I can do there is I can swap those around, can't I? 3 to the x squared, because this is 3 to the 2x, so is this. I'll show you why we've done that in a second. 12 times 3 to the x minus 27. Look what we've got here now. If I pull everything over this side of the equation, 3 to the power of x squared minus 12 times 3 to the power of x plus 27 equals 0. Is this starting to look like a trinomial? Maybe a quadratic trinomial where my my subject, if you like, is 3 to the power of x. So I've got something squared minus 12 times that something plus 27 equals 0. It's looking a bit trinomialish. Maybe you've seen this sort of technique before. What I'm going to do, the technique here is whatever that is there, we're going to bring in, say, let y equal to that, 3 to the power of x. You can also see it there, can't you? 3 to the power of x. So if I let y equal to 3 to the power of x, then what I end up with is not 3 to the power of x squared, but I'll go back to my black pen. I get y squared minus 12, not times 3 to the x, but 12y plus 27 equals 0. So this is a really important step here, letting y equal 3 to the power of x, just bringing in another variable just to help us solve the equation. Because now this is a quadratic trinomial, isn't it? And I'm looking to factorize this. This is if you've forgotten how to do factorize a trinomial. It's like this, where you're looking for two numbers here that multiply to 27 and add to minus 12. And you're bringing in, what are those numbers? I reckon they're minus 9 and minus 3. Are they going to do the job for us? Alright, they add to minus 12, they multiply 27, so that looks pretty good. So y minus 9 is there, and y minus 3 is there. So minus 9 and 3 slot into those spots. So what have we done here? We've solved y equal to 9 or 3, but we're right back at the top here. We're not asked to solve for y, we want to solve for x. So this is our time now to bring 3 to the x back into play, because y is equal to 3 to the x. We made that substitution, so we need to sub that back in now. Y is 3 to the power of x. So 3 to the power of x is 9, or 3 to the power of x is 3. And we can see here now we're back to getting the same base on either side. 3 to the power of x is equal to 3 to the power of 1. So now we've got our x equals 2 or x equals 1. Alright, so that's just a little bit more involved, but it's about identifying, isn't it, really? Look at that, 12 times 3 to the x. Or can I write this as 3 to the 2x? That'll be 3 squared to the power of x, or 3 to the power of x squared. And so I end up with a quadratic type equation that I can use quadratic techniques on. Okay, that's probably enough examples. There are some inequalities in the exercise as well, but we deal with those in the same way as we deal with equations. So we'll leave it at that. It's going to be exercise 15D when we next meet in class on Monday. I'll see you then.